Hello, students. Today, we'll be talking about the balancing of redox reaction. As you know, balancing of redox reaction is one of the difficult most topic there in chemistry from IIT JEE and NEET point of view. Students faces a lot of problems there in this topic. See, while balancing of a reaction, you should take care of the proper sequence of the steps involved there in any chemical reaction. First of all, reaction while balancing must be there in the ionic form. If it is written there in ionic form, then you need not to change it into ionic form. But if it is not written there in ionic form, then you should convert first it into ionic form. What does it mean? For example, K2Cr2O7 plus H2SO4. Instead of writing K2Cr2O7, you should write Cr2O7 2 minus. Instead of writing H2SO4, write SO4 2 minus. This is what the meaning of conversion of a reactants into their ionic form. Not only reactants, but product should also be written there in the ionic form. Now, after writing equation there in ionic form, what you should do next? You should take out the oxidation number of the elements which are changing their oxidation numbers. For example, in Cr2O7, Cr will be changing its oxidation number. So you'll calculate the oxidation number of Cr there on the left-hand side as well as on the right-hand side. And in SO4 2 minus, sulfur will be changing its oxidation number. So that sulfur there on the left-hand side and right-hand side, what oxidation number they are showing, you should calculate that. In third step, you will see how many atoms of Cr are there on the left-hand side and whether same number of atoms are there on the right-hand side or not. If it is not same, then make them same. Now, in fourth step, what we will see that Cr, while changing from left-hand side to right-hand side, whether getting oxidized or reduced, means how many electrons it will be losing or gaining. So that number of electrons lost and gained must be same there in Cr as well as in sulfur. Now, the last step of this balancing of redox reaction, you will check whether the charge there on the left-hand side is equal to the right-hand side or not. If charge is not same, then you will add H plus or OH minus there either on the left-hand side or right-hand side, wherever it is required. If reaction is taking place there in acidic medium, then you will be adding H plus on left-hand side or right-hand side. And if reaction is taking place there in alkaline medium, then you will be adding OH minus there on the left-hand side or right-hand side. And what number of atoms of H are there on left-hand side or right-hand side? There in case of acid or base, that is H plus or OH minus, half of that number of H atoms, number of molecule of water will be there on the opposite side. So these are the few basic steps, or you can say sequence of steps while writing a balanced chemical equation. Now we'll take an example to understand it in a better way. To understand balancing of redox reaction, this first example we have taken, and this example is based on oxidation number method or electron transfer method. According to this method, whatever steps involved, we will be discussing there in this example. As I have said, convert this equation there in the ionic form. Here, already these are there in ionic form, so you need not to convert them into ionic form. but this will be converted into ionic form. How that can be written? Cr2O7 2 minus plus SO3 2 minus, and there in acidic medium will be changing into Cr3 plus and SO4 2 minus. So now, as we have written, this K2Cr2O7 plus Na2SO3 will be giving Cr3 plus and SO4 2 minus ions. They are in acidic medium. They are in ionic form. As I have already told you, this would be the first step when you will be converting compounds into their ionic forms. Since here, this was there in compound form, was not there in ionic form, so you need to convert them into ionic form. But if it is already written there in this form, then this first step won't be required. So this is the maximum number of steps what I discussed there in the beginning of this video, that 5 steps you need to address to balance there in this redox reaction. Now see, first step you have done there in ionic form. Now see, second step, we will calculate the oxidation number. We will calculate the oxidation number of what? We will be calculating the oxidation number of those species which are changing their oxidation numbers. Here, there in Cr2O7 2 minus, oxidation state of this Cr is to be calculated. So Cr are 2 in number, so that's why you have written 2x. Oxygen is -2. 7 oxygen atoms are there, so -2 into 7 will be -14, and the net charge there on this Cr2O7 2 minus is 2 minus, so that you will be writing 2 minus. Now if we'll calculate x, this will be 6 plus. So here, what oxidation state this Cr is showing? 6 plus. And what oxidation state here? Cr is showing 3 plus. So there is decrease in oxidation state by 3. Now see the next one. Here, what oxidation state the sulfur is showing? So calculate it, SO3 2 minus. That is x minus 6 is equal to -2. So x will be equal to +4. So here the oxidation state of this sulfur is +4. And what oxidation state the sulfur is showing here, that we need to check. SO4 2 minus. So x minus 8 is equal to -2. So x will be +6. So here the oxidation state sulfur is showing 6 plus. So 4 plus is changing to 6 plus. That can only be done by losing electron, and this can be done by gaining electrons. And as we know, gain of electron is reduction, and reduction always takes place at cathode. And this loss of electron is oxidation, and we know oxidation always takes place at anode. But before going to the next, what you should do, you should check the oxidation state of all these elements, which is already done. Now see their second step you have done, that you have calculated oxidation number. Now see what you will do. Here, there on the left hand side, number of Cr atoms are 2, and there on the right hand side, it is 1 only. So we'll write the number of atoms there on the left hand side as well as there on the right hand side, same. So what we will do, twice Cr3 plus, and this is SO4 2 minus. Now see here, this Cr is 2. One Cr is having 6 plus oxidation state, 2 Cr will be having 2 plus. And here this is having 6 plus. 1 Cr is having 3 plus, and 2 Cr will be having 6 plus charge. Now see, 12 plus is changing to 6 plus. How that can be done? By gaining 6 electrons. As I have already said, gain of electron is reduction, and reduction always takes place at cathode. Now see here, there in this case, this is 1 in number, this is also 1 in number, this is showing 4 plus, this is showing 6 plus. So this 4 plus is changing to 6 plus by losing 2 electrons, and this loss of electron is oxidation, and oxidation always takes place at anode. Now what you should do, you should make the number of electrons lost and gained same. Here 6 electrons are lost, here 2 electrons are, here 6 electrons are gained, sorry, and here 2 electrons are lost. Number of electrons lost and gained must be common. So you have to multiply this by 3 so that the number of electrons lost will also become 6. So you will write it Cr2O7 2 minus plus thrice SO3 2 minus will be giving twice Cr3 plus thrice SO4 2 minus. Now the number of electrons lost and gained is same. Now in last step, what you will do? In last step, you will see what charge is there on the left-hand side. Left-hand side is having what charge? This is -2 and this is 6 minus. 3 to the 6 minus. So 6 minus and 2 minus will be 8 minus. And right-hand side, what charge is there? This is 6 plus and this is 6 minus. 3 to the 6 minus and 3 to the 6 plus. So 6 plus 6 minus will be 0. So right-hand side is having 0 charge. Now see, this reaction is taking place there in acidic medium. What does it mean? H plus. H plus, which side H plus will be added so that both sides will be having same charge. So that H plus must be added there on the left-hand side because left-hand side is having 8 minus. So Cr2O7 2 minus plus thrice SO3 2 minus plus 8H plus. Why 8H plus there on the left-hand side? Because left-hand side is having 8 minus charge. So make that charge 8 minus equal to the right-hand side. You have to add 8H plus there on the left-hand side. Why H plus? Because it is in acidic medium. Now what you will get? Twice Cr3 plus thrice SO4 2 minus. See, you have added here 8H plus there on the left-hand side. To balance H, what you should do? You should write 4H2O there on the right-hand side. Now, H there on the left-hand side and there on the right-hand side is same. Cr is also already same. Sulfur is also already addressed. Now, oxygen is left out. So 7 oxygen and 3 3 is a 9. 9 plus 7, 16 oxygen are there on the left-hand side. And on the right-hand side, 3 4s are 12 plus 4, 16 oxygen is there on the right-hand side also. So this equation is balanced. One last very important point, as I have already said, ionic form will always be there in aqueous form. So always mention whenever you are writing ions, there you should mention this aqueous solution state, then only it will be correct and you know water is liquid. So now this is balanced chemical equation using oxidation number or electron transfer method. So Cr2O7 2 minus aqueous plus thrice SO3 2 minus aqueous plus 8H plus aqueous will be giving twice Cr3 plus aqueous plus thrice SO4 2 minus aqueous plus 4H2O. See here in this second example, which is a disproportionation reaction. In this reaction also, we are using oxidation number or electron transfer method. You have said it's a disproportionation reaction which is taking place there in acidic medium. How we can say it is a disproportionation reaction? See, the same element is getting oxidized as well as same element is getting reduced. So same element is getting oxidized as well as reduced. That's why it's a disproportionation reaction. Now see, we will check what oxidation state this iodine there on the left-hand side is having 0. This 0 is changing to here IO3 minus. X minus 6 is equal to -1. So X will be +5. So here on the right-hand side, there in IO3 minus, iodine is showing 5 plus oxidation state, and that 5 plus oxidation state, that is loss of 5 electrons. And as we already discussed, that loss of electron is oxidation and oxidation always takes place at anode. This is the first one where iodine is getting oxidized. Now see here, this iodine here, is 0, and here iodine is 1 minus. So this 0 is changing to 1 minus, that is in decrease in oxidation number, and by addition of electron only this can be done. So in this way, same element iodine is getting oxidized into IO3 minus as well as getting reduced into I minus. So that is why it's a disproportionation reaction. Now we'll start balancing this equation. See, iodine is changing to IO3 minus. Here, how many iodine atoms are there? Here, how many iodine atoms are there? Here, 2 iodine atoms are there, but here it is 1 only. So write twice IO3 minus. This is 0. 1 iodine was having 5 plus charge. So 2 iodine will be having 10 plus charge. And how this 0 can be converted into 10 plus? By losing 10 electrons. Now see, the second part, iodine is changing to I minus. Now see here 2 iodine atoms, here 1 iodine, only iodide ion only. So write twice I minus. So here 0 and 1 iodine is having 1 minus, 2 iodine will be having 2 minus. So here 2 electrons are added. Now see, to make the number of electrons lost and gained same, what you will do, you will multiply this by 1 and this by 5. Now both will be having number of electrons lost and gained same. So iodine is changing to 2IO3 minus, and then in the second case 5I2 is changing to 10 10I minus. Now what you will do, you will add both of them. You will add both of these equations. So 1I2 and 5I2 will be 6I2. And 6I2 will be giving you twice IO3 minus and plus 10I minus. As in question itself, this is written, this reaction will be taking place there in acidic medium. So acidic medium means H plus. So on which side H plus will be added? On that side, so that the charge there on the left hand side and right hand side will become equal. Left hand side, what charge is there? On left hand side, 0 charge is there. And on right hand side, what charge is there? 2 minus and 10 minus. So that is 12 minus. To make the charges there on the left hand side and on the right hand side equal, what you should do? You should add 12H plus. On which side? On right hand side. Why on right hand side? Because this is 0 and this is 12 minus. So 12 minus and 12 plus will become 0. Now see, you have added 12H plus there on the right hand side because this reaction was taking place there in acidic medium. So to balance this, what you should do, you should write half of the number of water molecules there on the opposite side. Here 12H plus there on the right hand side. So 6H2 will be there on the left hand side. What you will get? You will get twice IO3 minus plus 10I minus plus 12H plus. Now see, this is balanced chemical equation. Now see, there on the left hand side, 12 iodine, 2 iodine and 10 iodine. So 12, and on left side also 12. Hydrogens 12, 12. Now iodine 6, oh sorry, now oxygen, 6 oxygen there on the left hand side, and right hand side also 6O is there. So now equation is balanced. But see here, that is a unique, you can write it there in this form, or you can simplify this too. Why? Because here is stoichiometric coefficient 6, 6, 2, 10, and 12. All these stoichiometric coefficients are having common factor 2. So you can write it there in this form also. 3I2 plus 3H2O will be giving IO3 minus plus 5I minus plus 6H plus. So you can write there in this way too. Now see, as I already told you, these are there in ionic form. So there you will be mentioning aqueous. There you will be mentioning aqueous. Iodine, you know, is solid and water is liquid. So you should mention physical state of reactants as well as products too. So this is disproportionation reaction balancing there in acidic medium. Now we will see one more reaction which is disproportionation and will be there in basic medium. So in this iodine from left hand side changing to right hand side, here 0 and this is 5 plus as it was in previous case oxidation. Now this iodine is 0 and here iodine is 1 minus. So this is reduction and this one is oxidation. What is the difference between this equation and the previous one? Previous one was in acidic medium. So that is why there H plus was there. And this is there in alkaline medium. So here OH minus is there. Now see, the same way as we have done there in the previous case, we'll convert this I2 into IO3 minus here 2 iodine. So there also you'll be writing 2 iodine. One iodine is having 0 and here another iodine will be having 5 plus oxidation state. One iodine is having 5 plus, so 2 will be having 10 plus. So here 10 electrons are lost. Now in second part, I2 is changing into I minus. Here 2 iodine, here 1 iodine, so you'll be writing twice I minus. So there 2 electrons will be added. Now see here the electrons are lost. So this is oxidation and here electrons are gained. So this is reduction. As I have said that reduction always takes place at cathode and oxidation always takes place at anode. Now see, to make the number of electrons lost and gained equal, you need to multiply this by 1 because the LCM of 10 and 2 will be 10. So you have to multiply this by 1 and this by 5. Now both will be having same number of electrons lost or gained. Now see what next is here. You have multiplied this by 1. So I2 is changing to twice IO3 minus, and here it is multiplied by 5. So 5I2 will be giving you 10I minus. Now, what you will do, you will add both these steps. So 5I2 plus 1I2 will be giving you 6I2. 6I2 will be giving you twice IO3 minus plus 10I minus. Now see, there on the left-hand side, what charge is there? On the left-hand side, charge is 0. And on the right-hand side, what charge is there? 10 minus and 2 minus, that is 12 minus. 12 minus. Now see, 12 minus. Now see, since it is an alkaline medium, means OH minus will be added. So right-hand side is having 12 minus charge and left-hand side is having 0. So on the left-hand side, add 12 OH minus. So 6I2 plus 12 OH minus. Now charge there on the left-hand side and right-hand side will be same. That is 0. So now this is done. Now see, you have added 12 OH minus there on the left-hand side. Half of this 12H is 6 H2O that will be written there on the right-hand side. Here too, stoichiometric coefficient is having common factor 2. So divide all these numbers by 2. What you will get? 3I2 plus 6OH minus will be giving you IO3 1 minus plus 5I minus plus 3 H2O. In this way, this reaction is valid. So that's all about balancing of an ordinary reaction as well as a disproportionation. Balancing of disproportionation is very difficult. Balancing of disproportionation is very difficult. So in this way, you can balance a disproportionation reaction too. Thank you very much.